Okay, in lesson 5.1, we're going to be solving systems of equations by graphing. What this means, first of all, let's identify what a system of equations really is. It's a set of two or more linear equations in the same variables. You can see this example, equation 1, equation 2, are both linear equations in slope-intercept form with the variables x and y. A solution of a system of linear equations is an ordered pair that is a solution of each equation. Okay, so the first thing we're going to do is identify from a graph, after graphing both equations, the point of intersection. So let's start working on that. So in order to do this, you would have 3 steps. First would be to graph each equation in the same coordinate plane. And it's going to be most important if you start graphing to make things a little easier from the slope-intercept form. So you would want to solve for y. Step 2, estimate the point of intersection. Try your best to use graph paper, to make very neat coordinate planes, to use a ruler. All these things will help you be successful. Then step 3, check the point from step 2 by substituting in the x and y in the equation and see that it's actually true. All right, in your textbook, it goes through an example, and we went through this in class. If you're going to solve this system by graphing. So I'll kind of highlight a few things. One, in the first equation, let's see. Wow. Sorry, I'm trying to change the color and I really can't. So, Okay, I'll use some ink. So the first equation, I'll use green, and I'll identify some parts of the equation. So when we have it in slope-intercept form, remember that B is the place where it crosses the y-axis, and M, the coefficient of x, is the slope. So we look for B, okay? I'll put a box around B. For this first equation, B is a positive 5. We can see that on the graph, on the y-axis, right here, okay? So they first put down the point, 5. Then they use the slope. In the first equation, m is equal to 2. So the rise over run ratio would be 2 over 1, okay? So you could count from there up 2 in the positive direction and to the right 1 and put a point down right there and then use a ruler to extend the line. Or remember that a positive slope means that you could have -2 over -1. And sometimes like this, it might be easier to go down 2 and back, and then you can see that it actually would intersect right there. Okay, I'll change the color and I'll work with the second equation. So in the second equation, the y-intercept is -1, and that's on the y-axis right there. Okay, that's the y-intercept. My slope is -4. So as a rise over run, I have -4 over +1 or +4 over -1. So remember, when you have a negative slope, only the numerator or the denominator is negative, but not both. And so again, if I wanted to, start counting my slope for the second point, if I start counting down with that -4, I'll run off the graph. So it's better to count up with this second ratio here. So I'd go, 1, 2, 3, 4 up and to back 1, and then I get this point. And so when I draw that line, I can clearly see that that is actually the point where the two lines intersect, and then I name that point. Okay, so that's the estimation of the solution. It's the place where the lines intersect. I then have to check each work. What does that mean? Substitute in the values. So everywhere in the equation where there's an x, you need to put in the -1. Where there's a y, you put in a 3. Then just check your work, all right? So this is just questioning. Does 3 equal 2 times -1 plus 5? Well, 2 times -1 is -2. -2 plus 5 is 3, so it works. For equation 2, does 3 equal -4 times -1 minus 1? And -4 times -1 is +4. +4 minus 1 is 3, and it does work. So now we know that this is, in fact, the solution. So now we're going to try doing these. All right. So for the first one, we want to graph it. I'll graph them in 2 different colors for you. So I'll start with the -1, which is the y-intercept. So I put a point down. Let me try to see if I can get this thick enough so that you can actually see it. And you'll have to bear with me because I can't use a straight edge on the iPad when I'm recording this. Okay. And then my slope is a +1. So my ratio would be 1/1. So I could go up in the positive direction and to the right. Okay. Now I'm going to do my best to draw a straight line. And this is where estimation will come in play because this is going to be very difficult to see. I'll change colors and try this again. All right, so now I'm going to graph a +3 on the y-axis. Now this time my slope is a -1, which means I could go down 1, but I have to go to the right. Okay. Man, that's terrible. All right, and it's really hard to see, but you can kind of see the point at which the 2 lines intersect is right there. And so if I were to estimate what those are, if my lines weren't so thick and if I were using a ruler, I could see that the solution to this system appears to be 2, 1. So I think that my solution is 2, 1. And the only way to know for sure is to substitute it in. Remember, this is the x-coordinate, this is the y-coordinate. So I would say 1 has to be equal to 2 minus 1, and 2 minus 1 is 1, so it is. Okay, and then I've checked it off. It's true. I checked the second equation. 1 has to be equal to the opposite, of 2, plus 3. Well, -2 plus 3 is equal to 1, so it does work. So that is the solution, 2, 1. Looking at the second example, I'll use a couple different colors. All right, graphing the first. Now, here's something else. Because of the way this graph is already numbered, I'm going to change the y-axis, okay? I'm going to count by 2s, maybe. So I'll have 2, 4, 6, 8, 10, 12, and 14 would be that very top blue line. The same would happen going down. So I'll do my best to label these. So -2, 4, 6, 8, 10, 12, and 14. Now, if you have to change the label of the axes and you have to count by 2s, it works, and the reason I'm doing that is because I have to graph a +14 and a -10 on the y-axis as the y-intercept. That does not mean I have to change my x-axis labels, and I am going to count by 1s. So the first one is the 14. So I'll put a point right up there at the top. Now, when I am graphing my next point, remember that my slope is a -5, so I'm going to be going down 5 units, not 5 lines because I've counted by 2s. So that's going to take me to, and I'll try to make this line a little more precise. So I'm counting from 14, So I'll go down to 13, 12, 11, 10, 9. So I'm going to be halfway between the 10 and the 8 and over here on the 1. So right about there is about halfway between. So I have a really fine point. So if I'm going to draw that line, I could count my slope again, because it's going to be hard for me, so I might count my slope a couple times just so it can have a guide for where the straight line is. So intersect right there. Okay, so this is going to hopefully be my line, okay, for the first equation. Again, sorry about this not having a straight edge. For my second equation, I have to graph the negative 10. So that's going to be on the y-axis at negative 10. And the same thing happens when I count my slope. In this case, my slope is going to be positive 1. So I will go up to negative 9 and over 1, up and over, again, doing my best, up and over, up and over. So I can kind of see that it's going to intersect that line right there. So I can, and you can use a straight edge, so you only have to put 2 points down, but me drawing on the iPad, I have to put more points down. So now I can estimate the point of intersection right here, and I would label that point as 4, negative 6. So I'm going to say that my solution is 4, negative 6. And then I want to try it out. So I take negative 5 times 4, and I add 14, and that equals negative 6. I take 4 minus 10, and that equals negative 6. So I've checked both of them. And of course, you can write down the steps, but for lack of space on this presentation, I can't do that. All right. Next problem. The way that the axes are labeled is fine. So when I have y is equal to x, since I do not see a constant, that means that b is equal to 0, or it crosses the y-axis at 0. So I will put down a point at 0. And then my slope is 1, so I could go up 1 and over 1 and draw my line as best I can, as quickly as I can, so that I can try to get a straight line. All right, for my next line, I would graph at positive 1, okay, and my slope is a positive 2, so I could go up 2 and over 1, okay, which is the same as like down 2 and back 1, and I can see that right there is where it's going to cross the blue line. So I draw that line, and then I'm estimating my point of intersection right here at this negative 1, negative 1. And so I try it out. When y is equal to negative 1 and x is equal to negative 1, they are equal to each other. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1, so the second one checks out as well. So again, I'm graphing both equations on the same coordinate plane, and I'm looking for the point of intersection to name that ordered pair as my solution. The other thing that you have to keep in mind is that if the equation is not already in slope-intercept form, you will have to put it in slope-intercept form. So looking at problem number 4, I have to rearrange this, and so I have to subtract x from both sides and write y is equal to negative x plus 2. Now I'm ready to graph the two equations. I can graph the first one at negative 7 on this y-axis, and then since my slope is a negative 4, that would be a negative 4 over 1. Remember that we can do negative 4 over 1 or positive 4 over negative 1. And the second one's going to be better because I need to go up in the positive direction. So I'll count up 1, 2, 3, 4, and back 1. Again, I'm going to do this a couple times so that I can kind of get an idea of where this line is going to go. And this line, if I make it a little thinner here to draw a better line, would be about right there. Okay. My second one I'll do, and now I'm graphing this at a positive 2, okay, and it's a negative, so I can go down 1 and to the right, okay, which is the same as going up 1 and to the left. And then I can see that the point of intersection is right there. Okay, so I'll do my best to draw the straight line, and then I name that point where they intersect, okay, and it looks like they intersect right there. Okay, and that point is -3, 5. So the point of intersection for number 4 is -3, 5. That would be my solution, and then I check it. -4 times -3 is equal to 12. 12 minus 7 equals 5. That works. The opposite of -3 is 3. 3 plus 2 is 5, and that works. So I've checked both. Okay, I've checked both. Let's try the next one. In the next equation, the first equation, I need to subtract x from both sides. Okay, when I do that, the x's cancel out. I get negative y is equal to negative x plus 5. But slope-intercept form needs y by itself, not negative y. So the last thing I have to do is divide everything by a -1. Okay, I'll write it at the top. So I'll get y is equal to negative x divided by -1 is positive x. Positive 5 divided by -1 is -5. So this is my first equation. So if I'm going to graph this first equation, I would graph -5, and then my positive 1 looks like this. So I have this graph that kind of goes and goes and goes, or I can go in the opposite direction, okay? So that when I draw my line, try to connect all these dots like that. For my next equation, I'm going to be solving for y, so I'll add 3x to both sides. Remember, -x plus 3x is 0. That's what I wanted to happen. So plus 3x over here. So I'll get y is equal to 3x minus 1. So now I can graph the -1, and then I can count, up 3 over 1. Remember, I can also count down 3 and back 1. Okay, so that I can see the point where they intersect. Whew, that is the worst line ever. Okay, straight edges really do help. The point where they intersect is right here. Okay, and that point, if you look at it on the graph, is going to be -2, -7. So the last step is to double check it. If I substitute in a -2 for x, -2 minus 5 equals -7. If I take -2 times 3, I get a -6. -6 minus 1 is -7. So I've just checked that it works for both equations. Okay, that's an important part, an important step. All right. In number 6, if I subtract 1/2 of x from both sides, okay, this would become y is equal to -1/2 x minus 6, all right? Looking at the second equation to put it in slope-intercept form, -6x on both sides. So 2y is equal to -6x plus 8. Then I want to divide everything by 2. So that equation, I'll put it at the bottom, y would be equal to -6x divided by 2 is a -3x, and 8 divided by 2 is 4. So here's my two equations that I can graph. So if I start with the -6, and then my slope, now my ratio is already there. I have a negative, so I can choose which one I want to be negative. Do I want a -1 or a +1? And I think I might want a +1, so I can go up, but then I have to make 2 negative, and I go back 2. So this would be, oops, right there would be my second point, right? Up 1, back 2. Up 1, back 2. All right, and that's a negative slope. The other one would be if I went down 1, I'd have to go to the right 2, which takes me right there to that point, 2, -7. So this is my first line. Whew, very sloppy that it is. And then my second line could be a +4, way up here. That's weird. Right there. And then a -3 slope. So if I'm coming down 1, 2, 3, and over 1, 1, 2, 3, and over 1, 1, 2, 3, and over 1, 1, 2, 3, and over 1. So it looks like right there is where it's going to intersect off the graph. Of course it is. All right. So let's see where that is. It looks to me, if I look at the place where it's intersecting, okay, and estimating, it looks like about right here, and that's 7, so that might be 8. So let's call it, so that's a 4, -8. So let's call it 4, -8 as my estimation, because I went off the graph. And then let's try it. So if I multiply a -1/2 times 4, I'll get a -2. -2 minus 6 is -8. So that one works. How about -3 times 4 would be a +12. Nope, sorry. That'd be a -12. -12 plus 4 is -8. So it works for both. So that is actually going to be the solution, 4, -8.